guess it is recording. All right. Thank you for the idea. All right. Okay. So here we go. We're building the unit circle as far as the angles are concerned in degree form and in radian form. And we're doing it with fractions. So the blue ones are showing increments of pi over 6, otherwise what we know as of 30 degrees. So here's 30 degrees. 30 more would be 60 degrees. 30 more would be 90 degrees. 30 more would be 120, so on and so forth, 150, and we're only going to do half of it for right now, for instructional purposes, so we don't lose time. 180. We good? Now, the way we did this is, how many of these 30 degrees does it take to get to this 60-degree angle? It takes 2 of these to get here. You with me? So pi over 6, that's my reference angle. And if I'm doing 2 of them, then the 2 over 1 will reduce with the pi over 6 to what? Pi over 3. That's why this right here is going to be pi over 3. Now, here we go. We're about to slice new pieces, okay? I'm now going to reference pi over 3 and say from 0 to pi over 3, that's a slice. How many of those does it take to get to pi? 3, because your goal is to get 3 pi over 3 to cancel to just 1 pi. Okay? So we have 1, 2, here we go, which is 2 pi over 3, because it's 2 of these, or it's twice as big as 60. However you want to look at it, I want you to develop the fractions, and then we, of course, have pi over here. Okay? So now, we're building these from fractions as far as those reference angles are concerned. Let's go to the new stuff of what we're talking about for today. Triangular trigonometry. Alright, so first, let me pause the video because I think some of you don't have this sheet that I got to give to you real quick. Okay, so what we're going to learn today is basically we're putting geometry, listen, we're putting geometry and algebra 2 mixed together. Okay? So geometry, you just had like a bunch of shapes, right? Specifically, triangles and circles were big shapes. And what we're going to do is we're going to bring those shapes together, per se, into, here we go, let me show you visually. We're going to bring them together where they look like something like this. So on a graph, it would look like that. And then furthermore, we're going to bring the algebra 2 stuff into it, okay? So when we bring the algebra 2 stuff into it, we're talking about specifically, let me make this a little bit better. We're talking about, let's make this the origin, and let's make this an XY graph. So we're overlapping concepts of algebra 2 and geometry together to do the trigonometry that we're doing, okay? That's what's happening. Now, let's come back over here. What I want you to do is I want you to concentrate on this triangle that they drew. And the biggest thing about it that I care about right now is the fact that it comes from the center. Okay? So the way I'm going to start this off is, let's say that I have a point right here. Okay? Let's call this point XY. Now I know it's already drawn out there, guys, but to see it getting developed, that's where you learn why things are the way they are, okay? So XY, first step. You need to draw a line from here straight to the center. Second step, draw a straight perpendicular line straight to the x-axis. Okay? That's it. You just now built something called, referred to as, your reference triangle. Now, let me ask you, what would this be? Would it be the x or would it be the y of this point up here? It would be the x. See, and some of you can answer pretty fast because you can already see the spatial awareness. As far as this goes, putting it together, right, it's talking about the y value. You with me? Now, from this, that's what we're looking at, is we learned in geometry that this could also be a squared plus b squared is equal to c squared. Otherwise, you learned also that this could be x, this could be y, and this could be z. But now what we're going to say is, we're not going to say it's z, we're going to say it's r. Why do you think they choose the letter r? Radius of what? The circle of what we're drawing. Okay? So if we're looking at the radius of the circle, that's why we choose r. Now, up until now, you see sine of an angle, and we've used it with SOHCAHTOA. What sine SOHCAHTOA was? Good. Opposite over hypotenuse, like the speed as well. Opposite over hypotenuse. So now, if I'm using this triangle, the opposite, I'm not going to put it as O anymore. No more. I'm going to always put it as what? Y over what? R. Nicely done. So the sine of theta is actually now y over r. So we'll say, whoops, we'll say sine. Sine of theta is y over r. Let me ask you right now. What would cosine be? Okay, it is adjacent over hypotenuse, but now I want you to think of it not as adjacent over hypotenuse, but what? X over r. Oh, sorry. Yeah, x over r. Nicely done. Let's look at tangent. Tangent is going to be what? Y over x. And see, right now, guys, a progression. How you learn this stuff, and in the order that you learn it, will make a lot of stuff very easy, okay? Now, this right here is called cotangent. This right here is called cosecant. And this right here is called secant. Okay? And they're the reciprocals. Underline that, bold it, circle it, whatever. They're the reciprocals of other pieces. So in other words, the reciprocal of sine is cosecant. What does reciprocal mean to you so far? Just flip it. You don't do a negative flip, you just flip it. Okay? So if you were to look at sine and flip it, what would I put over here for cosecant? R over y. Now to me, do I expect you to remember that cosecant is r over y? I really would not want you to, because it's more information that you got to memorize. What I would want you to remember is this. Cosecant and sine, they're just flips. Okay? Secant will be what? R over x, because it's the flip of cosine. And then tangent will be what? X over y. Now look, cotangent and tangent are so easy to remember because you know they're pretty much the same thing. And they're just the flips of one another. But secant and cosecant, they're a little bit different. To me, the way I remember it, look, sine, I read that and I say S is in between the C's. That helps me remember that this is the reciprocal of sine. Okay? And yeah, I'm weird like that. And then the other one that you could do is, if I spelled cosine backwards, it's pretty close to secant. That's to help you remember, okay? Memorization-wise. Do use whatever you need to. But you got to know all 6 of them. All right. By memory, yes. Are you ready? Here we go. What we're going to see now is how are we going to use this in the problems that are coming. A reference triangle is what we just built on the last slide. And we built it by doing a perpendicular segment from a point to the angle's terminal side to the x-axis. All that fancy words of just saying, guys, when you get a point here on the circle, you build the triangle by going straight to the center and straight to the nearest x-axis and create your triangle. Done. Okay? And then put the angle right here. Are you with me? Oh, and you're going to get your test back here right before class ends, and I can answer a couple questions on that too. All right, any questions as far as reference triangles? All right, so let me ask you this. If I built this reference triangle here, what's wrong about it? It's attached to the y-axis, and that's not a reference triangle. I would look at a reference triangle like this. Straight to the center, go to the x-axis, there's a reference triangle. Okay? Now you tell me, what would this angle be by guesstimation? About 45. The reason why we call them reference triangles is because guess how many pieces people who struggle with that quiz that I was telling you about, how many pieces do they try to memorize? They try to memorize 1, 2, 3, 4. But if you can only reference the first quadrant, all of these are mirror images of the first quadrant across the x-axis and or y-axis. You with me? So for instance, here we go, watch this. So I have 45 degrees, otherwise pi over 4. This is how many degrees? Not 90, not 150, 135. Because look, 45 more is 90. 90 plus 45 more is 135. So 135, or how many pi over 4s? 3. Okay, good. Now, all of these, the reason why reference angles are shared is because whatever this x value and y value are, they're going to be the same here, they're going to be the same here, and they're going to be the same here. The only difference that they will have is what? Positive and negative. You have some that are negative x, positive y, negative x, negative y, positive x, negative y. But they're all going to be the same number. You with me? That's why we reference just one quadrant, okay? Here we go. Let's go to the practice problems. Let's go to right here. It says sketch the angle in standard position and indicate the quadrant where the terminal side lies. Evaluate the 6 trigonometric functions of the angle and leave the answer as simplified ratios. So what we're going to do is we're going to look at these angles as far as where do they go, where do they belong, and then we're going to build them here in just a bit. Now, you don't have this. We're going to practice with this here in just a bit, so don't freak out. I don't want you worried about writing this. We're going to practice with it. I want you more concerned on looking at this right here. Let me show you. 7, day 2. 7, day 2, 7, day 2, 7, day 2. There's 1. Here comes 7, day 2 up top. So what I want you more with right now is this right here. Okay? Positive trig values. I'm looking at when are the sine, cosine, tangent, cosine, or cosecant, secant, and cotangent, when are they positive? Okay? This is how I would like for you to learn. Here, it's positive, positive. I'm talking about x and y. Here, it's negative, positive. Here, it's negative, negative. And here, it's positive, negative. Otherwise, a positive x and a negative y. Now, if I asked you to tell me which trig functions or trig functions are positive in the first quadrant, you would say all. Here it's only sine and cosecant in the second quadrant. Third quadrant, fourth quadrant. Now, I don't want you to memorize necessarily this acronym. It really doesn't help all that much at the beginning. All, students take calculus. So the cosine and its flip is for the C. This take, the first letter is tangent, or T for tangent, so it's going to be cotangent and tangent are positive. All this is, I think it's still too much to remember, and it really doesn't help you. The way I want you to memorize it is this way. Watch. All right, we have cosine of an angle, and the way I want you to look at this forevermore is I want you to look at cosine as an x value. Okay? I say cosine, you say x. If I say sine, you say what? Y. And just like we did before, if I say tangent, you are thinking, or you say what? Y over x. These are not the R related yet. Okay, we'll look at that here in just a bit. So, the cosine is x. So, you tell me, on this Cartesian plane coordinate system, when is the x positive? What quadrants is the x positive? 1 and 4. So cosine will be positive here and also here. And the reciprocals of cosine. You with me? Let's do sine. Sine is the y value. When are the y values positive? 1 and 2. Because that's when the y value is positive. Are you seeing how I'm doing this? Okay? The tangent is, when is the y over x, when is that positive? You tell me. 3 and also what? 1. Because look, this positive y over a positive x would be, look, y over x looks like this. What's that? Positive. Right here, look, y over x. What's this? Positive. That's how I would want you to learn it. Not that all students take calculus, but it's an acronym to help if that helps. Questions? Let's see where you're at. Yeah.
We're gonna have to know exact values like the chart.
Yeah. And I'm telling you, those exact values that we're talking about right now is what takes people a long time to understand, because they're trying to memorize it, and that's too much to memorize. Like, you have a lot of other classes of other stuff to memorize stuff. This is not one of those. The way I'm showing it to you, I want you to learn that process, because the memorization after that, I promise you, is within seconds you can develop that unit circle. All right. Let's keep going. All right, so this right here is what was on notes, and I want to kind of go through this together with you, okay? On notes, watch what they do. This problem right here of 12, -5 is what we're going to do for this here in just a bit, okay? So let's come back over here and do it on this page. Here we go. My angle, oh, go ahead. I'm sorry. Oh, no, you don't need that page, but what you can do is that you can, see how this is handwritten? You don't need this page. I want you to handwrite it, because you practicing writing it out is what's going to develop your spatial awareness of what should go what. Okay? Can you watch it and still get it? Yeah, you can watch it and still get it too. Okay, here we go. This will be on page 29. Okay. So, the very first thing that they give us is an angle theta and a point 12, -5. Already, from what I've talked about, if I told you to, I want you to envision where 1245, or sorry, where 12, -5 is. What quadrant is it in? 4. And 4. Because a positive 12 and a -5, it would be right here as a point. Quadrant 4. Because remember, it's 1, 2, 3, 4. Okay? Now, looking at this, what do I do from this point? What did I show you from the other slides? What was I needing to do? I need to make the reference triangle by drawing 2 lines from this point. The first one goes where? to the origin, and the other to the x-axis. And there it is. There is my reference triangle. Okay? The question now is, where does the theta go? Watch. Let me get a smaller highlight. Does it go where the blue is? Does it go where the green is? Where does theta go? It goes where the green is. Okay? So it's the angle that's formed between the x-axis and that nearest hypotenuse, if you will. Now, some of you might look at this and you're like, that's a little hard to see. And if you need to make it a bigger triangle, by all means do so you can understand it clearer on your paper. There we go. What is the sign that we said now I want you to know sine? So before, look up here please. Sine was opposite over hypotenuse. But now I don't want you to think of sine as opposite over hypotenuse anymore. I want you to think of sine as what? Y over r. What's the y value? Negative 5. And that's where a lot of people get a little confused, okay? So let's look at this. This is negative 5. And what's the r value? We don't know that yet, do we? So we know that if this is negative 5, if I were to look at it like geometry, that could be like saying this is 5 and this is what right here? 12. So if I do a squared plus b squared is equal to r squared, otherwise our hypotenuse, right? I'm going to get 144 plus 25, and then 169. R is what, anyone? 13. So from theta, put your body where theta is at. The sine is that y over r. What's my answer? Negative 5 over 12. Or sorry, 13. Go with me? Alright, so this is 12. This is 13. Can the x ever be negative? Yes. Is the x negative here? No, it's a positive 12. But I'm asking you, can the x ever be negative? And the answer is yes, because it could be, the point could have been in what other two quadrants? 2 and 3. Yes. The 13, you have to do Pythagorean Theorem to get that r value. Okay? Now, let's go to 13 real quick. 13 is an r. Can the 13 r value ever be negative? No. Why? Because a radius can't be negative. Well, why can this x and y be negatives? Why can those be negatives, but the radius can't? Say again?
They're coordinates, not lengths.
Their coordinates, well, their coordinates and lengths is the thing, where the radius is just a length. Okay? That's huge right there, okay? The other part is this. When you do Pythagorean Theorem, what Eric was talking about, to get r, you're always going to have a what number? A positive number. Because you're going to take the square root of a positive 169. Now, we know it could be plus or minus square root of 169, but the context of this, they were saying you can't have a negative length for a radius. My last question, then we'll keep going. One more time, I want you to hear it out of your mouths. Why can I have a negative x and or a negative y? Because they're coordinates. They're locations on this. As far as, guys, I could be up here or here or here or here. And they're showing the locations by having negatives and positives. Okay? Alright. So, with that being said, let's go to cosine of theta. Let me call on some people. And no worries if you don't get it. Say it loud and proud even if you don't get it and you struggle a little bit. Cosine of theta. Said, what would it be? X over r. He's right. So, Said, from theta, what is x over r? 12 over 13. Perfect. That's the way I want you to answer, just like that. Tell me the ratio first, and then give me the answer. Okay? Ellen, what would tangent of theta be?
Y over x.
Okay, so y over x. Let's do y. Oh, that's not y. Let's do y over x. And Evelyn, what'd you get? Perfect. Okay. Now, the other three, let's do cotangent. Okay? Let's do cotangent. Lauren, what's the cotangent going to be?
X over y.
Okay. X over what?
X over y.
X over y. Yes, you can say x over y. Now look at the picture. That's x over y, which is what? 12 over negative 5. I could memorize one more thing of saying, cotangent's x over y. Or I can just memorize tangent, figure out what the tangent is, and do what? Flip it, the reciprocal. So secant, what does that match up with? Not sine, remember, spell it backwards. Cosine.
On this it says negative 12 over 5. Does it matter if the top is negative or the bottom is
We'll talk about that here in just a bit. Let me get the numbers and then we'll segue to that, okay? Because that is very important. What is the secant anybody going to be? X over r, otherwise the flip of cosine, which is what? 13 over 12. Cosecant is the flip of sine, which would be what? 13 over negative 5. You with me? Guys, the whole x over r, y over r, and r over x versus r over y, if you just memorize these three and know that the other ones are flips of them, that's an easier route for where you're going to go with the math. Okay? Now, Gabe asked a really good question. He said, he's basically asking this. Let's look at cotangent. Is that the one that you were wanting to look at? Okay. Cotangent is x over y. Otherwise, 12 over negative 5. Now, let me ask you this. Would this be the same if I wrote negative 12 over y? Yes or no? It is. Mathematically, they're equal. They mean the same exact thing, and whichever one you wrote would be full credit. Do you understand? Now, when I'm doing the r's, we did have the discussion. We were saying r cannot be what? Negative. But whenever I have something like this, my r is 13. Let's look at sine. We said it was negative x over a positive r. This is still the equivalent, guys, to this. They are still the same. Now, I don't want you getting so nitpicky that you're like, no, you can't have a negative r, you can't put the negative down there. No, because you're going to be given stuff like this. And if you know this is cosine, you have to interpret, okay, the r is going to be positive, so the 13 is actually positive, and this will tell me it's a negative x value of 5, so I should be in quadrants 2 or 3. Do you understand? Now, you have to practice with this. This is not a, you can just watch me do it and you got it. It's not one of those. So we're going to do plenty of practice. This is why we're going through, making sure that you're thinking about the location of these points. Okay, let's do the next one. I'm going to take off everything so that you're not all cluttered with too much. And let's look at the next one. Okay, so we're going to look at, let's go to 3. It says the theta, the angle. Now this one is a weird, like a phi kind of notation, and who cares what the variable is. You could treat it as theta, as x, as whatever. It's just the angle. Okay? The point is negative 12, negative 5. It's about here. I'm going to draw a straight line to the center, straight line to the nearest x, right angle. And my phi is going to be right there. Now, let's do the sine. Megan, what's the sine going to be? So, sine is y over r. Okay? So, what would your answer be? So, Here we're going to do a little bit more practice, a little bit more labeling before we start going to our trig functions. Okay, let's do some more labeling. Can someone tell me what I should put here for a number? Negative 12. And then, remember, because that's the x value. And x's go left and right. Y values go up and down. So what am I going to put here? Negative 5. Now look, if this was geometry and we didn't put it on the xy graph, could we have them as negatives? We could not. We didn't need positive numbers. Because you're showing it like an object in space, not location with quadrants. You with me? Alright, so Megan, go ahead and finish off. What would the sine of phi be? Over? That's the y value. What's the r? So we got to find r, right? Here we go. A squared plus b squared is equal to r squared. And what would it be? 13. Because remember, the 25 plus 144, it's basically using the same numbers that we used from the other problem. Okay? Alright, let's do cosine. Jeremy, cosine of phi would be what? Okay, there you go, negative 12 over 13. And guys, that's where all the mistakes occur. Too many people miss the negatives, okay? And the negatives can make a mistake this small occur, or they can make a mistake huge occur, okay? So be careful with the negatives. Alright, let's go to Judd. Tangent of phi.
It'd be negative 5 over negative 12.
Perfect. Negative 5 over negative 12, which would give me what? Anybody? Just a positive 5 over 12. So simplify my answer, right? It will be wrong if you don't, because that's what we did on the test, and you're going to see when you get your test back. We said simplest form. If you're not simplifying, that's part of your math maturity as far as the context that we're doing. All right, here we go. Cotangent. Some people might think of cotangent as what over what? X over y. But what would I hope that you would think cotangent of? Not opposite. No, not that. But just the reciprocal of what? Tangent. So what's tangent? 5/12. So what's the reciprocal? 12 over 5. Let's do the reciprocal of the next one. What would the secant be? 13 over negative 12 or negative 13 over 12. Either one, it's still going to be the same. Okay? And what will cosecant be? Yep, negative 13 over 5. And yes, that's the same as 13 over negative 5. Okay? Alright. So let's go back over here. And let's look at the other example that we have. Because I don't want to give you too many of the same types of numbers. I want to show you other numbers as well, okay? Alright. Let me block this out. Now, and yeah, I'm kind of showing you too much. But anyway, right here, can you tell me what is different about this problem from the one that we just did? They did not give me a point. They did not give me this. Okay? They gave me that it ends in quadrant 4. So I know, and this is the way you need to be doing your quiz and stuff, okay? You know that it ends here. You know there's a point somewhere here. Okay, we're going to figure out where it's at here in just a bit. And the tangent of an angle is negative 4/3. Why is this important? Why did they give me this? There's my y and there's my x value. I can say x is what? 3 and y is negative 4. Does this matter where the negatives go right here with the point that I just created? Yes. It does matter. So over here, negative 4/3 is the the same as 4 over negative thirds, but the way they give it to me, I have to make sure of where I put this location-wise. It does matter with my reference triangles in a sense. And you're going to see here in just a bit, with cosines and sines it matters. Tangents, you got a little bit of leeway. You're going to see why here in just a bit. Are we good? Okay. So I know that if it was 3, negative 4, it would end here. There's 3, here's negative 4. You with me? And it would look like this. But I also know that it could have been negative 3, 4. Which would have been negative 3 up 4, somewhere like up here. And the reference triangle would have been different. It would have been in quadrant 2. You starting to see a pattern start to develop here? Can you tell me if these angles are the same, yes or no? Yes, because they're what? They're vertical angles. They're vertical angles away from each other. They share the same vertex, okay? Now here's the thing. How would I know which one to do? There's all the pieces of what they give you. You got to read very carefully because it will help you know which one to draw. How do I know which one's correct? It gives you the quadrant. You with me? Now here comes the extension. I'm going to go straight to the difficulties kind of problems. If it didn't give you the quadrant, and it said that the tangent was this, what could it also give you to say that it was going to be in quadrant 4 without saying that it's in quadrant 4? Well, watch. They could have said this. The sine of G is what? Negative. Who said it? Okay, nice. The sine of G is negative. They could have said, I'm not giving you this information, but they better give me this because otherwise I won't know if it's in the 4th or the 2nd quadrant. Do you see how all this thing is overlapping? It's so comprehensive. You put everything together always on one problem. Okay? All right. Good. Good stuff. Good stuff. Because we overextended that, but you got it. All right. Here we go. So, y is going to be what? Right here. What's this? Negative 4. X is going to be 3. And what's my hypotenuse? 5, because it's a 3, 4, 5 right triangle. Okay? Now let's go ahead and figure out the sines, cosines, and tangents, and so on and so forth. So with all that, just to figure out what the reference triangle looked like, now look, the sine is y over r. You get negative 4/5. The cosine is x over r, and the tangent is y over x. And then what? This is the flip, this is the flip, and this is the flip. How you progress to this can be very easy. It depends on how you're shown, okay? And this right here, what we're doing right now without you realizing, it's called the Qrst method. We'll get to that here soon in just a bit. All right, look at this one. From what I wrote here, the sine of A, don't look at anything else. The sine of A is equal to this, negative 3/4. What do you think I want you already thinking? Where is this going to be? Which quadrant, right? So you tell me, when the sine is negative, what quadrants could it be in? 3 and 4. What's sine mean? X or y value. If you forget, guys, look at this. What comes first alphabetically? X or y? Alphabetically. X comes first, right? What comes first alphabetically? Cosine or sine? Cosine. So that's a good way to remember that cosine is x, sine is y. Because I can see it in your face. Some of you still didn't make that connection yet. Now, if the sine is negative, I'm saying already the y values are negative, so it must be in one of 2 quadrants, either quadrant 4 or quadrant 3. You with me? Now, it also said the cosine, which is the x value, is negative. So it could only be to the left of the y-axis, which is up in quadrant 2 or down in quadrant 3. The overlap happens where? In quadrant 3. That's how I know where to draw the reference triangle. So here's the dot. It's negative 3 over 4. I know sine is y over r, so the r is always positive. That's 4. And then the y value would be negative 3. Then I can finish drawing it out, do Pythagorean Theorem to get this as negative root 7. Look right here. Mathematically, it gave me 2. It gave me a negative and a positive. Why did I choose a negative? Because the x value in the coordinate system is negative. There's a lot to think about. Okay? And drawing these triangles, they're not as difficult as some people make it. But you got to ask questions now, okay? Don't wait till a day or two, because then the confusion marinates for a couple of days, not understanding. And we want understanding to happen. All right, so from angle A, sine is y over r. Cosine is x over r. Tangent is y over x. Notice that they rationalized the denominator. And then we just did flips. So the flip of negative 3/4 is negative 4/3. They did the flip, check this out, they did the flip and rationalized it by multiplying by root 7 over root 7. And then last but not least, they did the same thing here by flipping that. Now, let's see this in action, because again, watching this flip, here we go. This would flip to 7 over 3 root 7, multiplied by a form of 1 to rationalize the denominator, so that these two root 7s, these two root 7s in the denominator become what number? 7. So you have 7 root 7 over 3 times 7. Those cancel, and you're left with root 7 over 3. Questions? If not, remember, the only dumb question is the one that's not asked. Alright, the terminal side of an angle B passes through the point 0, 4. Find the other 6 trig ratios. Can I draw a triangle? I can? How do you draw a triangle from a point? You go straight to the center and straight to the nearest x-axis. There's no triangle. Okay? But could I do sine is y over r? What's the y value that you see on this point? 4. That's why it's 4 over r. It's still 4. That's why it's 1. Go with me? And then, over here, the cosine is the x over r, which is 0 over 4. Can you do 0 divided by a number that's not 0? You can. You can do 0 over any number, as long as this number down here, as long as the number is not 0, then it will be 0 as an answer. But can you divide by 0? No, that's undefined. Now watch this relationship. This is pretty cool. The cosecant is the flip of cosine. So that means it's the flip of this. If I flip 1, what do I get? I still get 1. Because down here there's an understood 1. Down here, it's still an understood 1. Okay, here we go. What number is below 0 that's understood? 1. Now if I flip 0 over 1, I get 1 over 0, you get undefined. How about if you flip undefined? You get 0, because undefined is 0 divided by, a number divided by 0. So if I flip it, right, I'm going to get 0 over some number. That would give me that. Okay? Alright, we're going to do one problem here in just a bit together. We're going to think about all of this that we just talked about. Okay, and I'm going to call on you. Just please be ready. Here we go. We're going to look at something called the Qrst method. Okay? We're going to create it with something that you... Okay, look. Q, find the quadrant. R, label the reference angle in the triangle. S, label special sides of the triangle. And T, tell the trig ratio. Okay? Here we go. Let's just create an equation or a problem just on the fly. Okay? Let's imagine that we're going to start from 0 degrees, right here, and we're going to travel a certain amount of degrees. Now, Eric, give me an angle between 360 degrees and 400. That's kind of small. Let me give you a different one. Give me an angle between 360 degrees and 600. Some number between 360 and 600. Huh? 450? Okay, here we go. 450, guys. We're all going to travel 450 degrees. And you tell me when to stop. Here we go. How much have we traveled? 90. How much have we traveled? 135. How much have we traveled? 180. That's too much math, but that's what we have to do to develop this unit circle, okay? We're going to keep going. How many degrees? 270. And what did I say we're going to?
450.
450. So 360. Now, how many more do we need to do to get to 450 from 360? 90, right? Wait, is that right? Yeah. Okay. So all the way over here, do we stop here? Okay. Now look. So 90, 360 gives us 450. We traveled, nice angle too, by the way, because the other one, no worries. So this is weird. What if I said, hey, you ended up here? Would you be able to tell how many times you went around? No. That's why in WebAssign, you're going to see the angles are shown like this. They show you going around one full time, and then it spirals showing that you've gone one full circle and then a little bit. If it wanted you to go even more, it will show you the spiral even more. You with me? All right. Who can tell me what the point is going to be right there? Like, let's do it this way. 0 and whatever this is, right? Whatever this length is, and guess what we call it for now? We call it R, because this is the radius of whatever that is. In unit circle, we want R to be 1. Okay? So this is a little bit too much extension of what I was wanting to show you today, but it's a really good one as far as what's coming. So let me do just a little bit less than that, and we're going to end up at traveling 360 and then 45 more. Okay, you ready? So 45 more. There's my reference triangle. I'm building it right now. Straight down to the nearest x-axis, and then straight to the center. And there we go. So this is 360 plus 45. This is a 405 degree angle. Okay, you ready? Now, the way I'm going to draw this, I'm going to put it as x, y, and what? R. Okay, so Q, what quadrant am I in? 1. So being in quadrant 1, my signs are this. Check. Okay? R, what's my reference angle? If I stopped here, yeah, it's going to be 45 because I'm going to subtract 360 to see how much was this reference angle. Okay? Yeah, it is a special right triangle. So, this is going to be, let's do the next one. Okay, is it special angles? Yes, it's a special right triangle. And the last thing is the trig ratios. You with me? Here we go. This is going to be it, and then we're done for today, okay? Now, looking at this and knowing that it's a special 45, 45, 90, I've taught you to memorize this. What goes underneath? An x root 2. Now look, this is where we're going. This is like the culmination. I'm telling you, with the unit circle, the radius, like, watch, this radius here, this radius here, this radius here, all these radii, the length is 1. 1 foot, 1 yard, 1 mile, it doesn't matter, it's 1. Okay? And you learned back on the last unit that if I set these equal to each other, and I were to solve for x, it would look like this. Those would cancel. I'd be left with 1 over root 2, but we don't accept answers like that. What do? We rationalize the denominator by multiplying by a form of 1. This becomes 2, and it's root 2 over 2.
Isn't that the exact value for sine of 45 degrees?
Yes, and we're getting to that. This is where all this comes from. So look, x is root 2 over 2. So this would be root 2 over 2. This would be root 2 over 2. So opposite from 45 is root 2 over 2. Opposite from this 45 is root 2 over 2. Now listen, guys, come on, stay with me. We're almost done. This is the origin right here. So you tell me, what would this xy coordinate be? What's the x value here? It is whatever this length is. True or false? True. So it is root 2 over 2. Okay, we're almost there. Yeah?
So we'll find all of that with any angle?
Just with the special ones. Other ones that are not special, we're going to have to get more information from trig values and stuff. We're going to use x over r, y over r, all those different things. Okay? And then, what's my y value going to be? Same, root 2 over 2. So, get this. 45 degrees, otherwise pi over 4 in radians. Okay, let me show that right here. Degrees is 45, we're almost there. I can see a lot of you about to be, anyway. So radian, pi over 4, I'm all excited. Let's go to, okay, we're in radian mode. You see it right here, radian mode. So if I say the cosine, oh, come on now, chill. All right, so if I say the cosine of pi over 4, it should say what? What did I say cosine was? Cosine is the x value. So it should say root 2 over 2. Let's see. Okay? And if I do the sine, surprise, surprise. So if I do the sine of pi over 4, what should it say? It should say the same. Root 2 over 2. Now watch. Last thing, and then we're done. Last thing. What if I said the tangent? You learned it today. Tangent is what? Y over x. So it'll be y over the same thing. It should give us what? Yes, I am. It's gotta, hey, you gotta create that suspense. What are you talking about? What is it gonna say? Is it 1 or negative 1? 1 or negative 1?
Both.
Y over x. 1 or negative 1? 1. It it'll be a positive 1. Boom.
Oh my god.
Alright, we're done, guys. If you got it, that was very rewarding. And if you're bored, please wake up.